Today we're going to talk about proportional and non-proportional relationships. We are also going to talk about how to write an equation in the form y equals kx from proportional relationships. Let's just talk about what it means to be proportional first. We can say that two quantities are proportional if they have the same ratio or constant rate. So, two quantities are proportional if they have a constant ratio or rate. For a relationship to be non-proportional, the rates are not constant. We're going to look at a couple of tables and decide whether or not there is a proportional or non-proportional relationship going on. So on page 26, if you could please get out your handout, let's take a look at number 1. So the directions say determine whether the set of numbers in each table is proportional and explain. So here we're talking cups of rice versus cups of water. If you've ever cooked rice before, you know that you need to put it in some water. So we have 1 cup of rice to 1.5 cups of water. That's basically the first ratio presented. So 1 cup to 1.5, 1 cup of rice to 1.5 cups of water. We want to look at the other values in the table and see if we get the same ratio. Now 1 to 1.5. We could simplify that if we wanted to make it a little bit easier. Get rid of the decimal. I can multiply by 10. That would give me 10 cups of rice to 15 cups of water. And if I simplify that down and divide by 5, I will get 2 to 3. All of these are equal, but sometimes it's nice to look at a ratio without decimals. So 2 cups of rice to 3 cups of water. If we look in the table, we get 2 to 3 next. So we know that the first two ratios presented are in fact equal. Let's take a look at the next ratio. We have 2.5 to 3.75. So again, to figure out whether or not these are the same, let's multiply this time by 100 to move that decimal over a few times. That would give us 250 to 375. When we simplify this down, we do get 2/3. So it turns out that that is equal as well. And then our last ratio given is 3 to 4.5. I'm going to multiply by 10, 30 45ths. I can divide by 15 and again get 2 to 3. So all of the ratios presented in this table are the same. That means that between the cups of rice and cups of water, we have a proportional relationship. So yes, this situation represents a proportional relationship. Because we have a constant ratio. And I can even say, of 2/3, of 2 to 3. What I would like you to do now is to take a look at number 2 and determine whether or not that situation, the miles driven and the toll fare, represents a proportional relationship. So hit pause, do that, and then hit pause again when you're ready to see the solution. Okay, so for taking a look at number 2, you drive 1 mile and the toll fare is $1.07. You drive 2 miles and the toll fare is $1.14. So the question remains, are these ratios equal? There are many different ways to figure this out. You could do what we did before and multiply by 100 and get rid of the decimals. You could use a cross product here. You could also just kind of look at it logically. How do you get from 1 to 2? Well, you'd multiply by 2. The question is $1.07 times 2 going to equal $1.14? No. It equals $2.14. So just by looking at it, you might be able to tell these are not equal. So we have a situation where we don't even need to look at the other ratios. We have two that are not equal, so this is not a proportional relationship. And we are asked to explain. So we can say it's because the rates are not equal. They're not constant. So that's identifying proportional versus non-proportional relationships. Take a look at number 5 on the same page. The directions here say determine whether the pattern forms a proportion. So text messaging. I'm sure you all text or know about texting. You can get different price packages per phone, per month. And in this case, let's say it costs Victoria 10 cents to send a text message. Okay, so number of messages versus cost. And we need to fill in the rest of this table. Well, they give us the first one 4. 4 times 10 cents would give us 40 cents. And then the rest of the table is blank. If you're not guided as to how many numbers of messages you need to fill in, you can choose to fill in whatever you'd like. I'm just going to go in order, consecutive numbers here. So 4, I'm going to say 5, then 6, 7, and I need one more, 8. But you can choose anything, 100, 10, 50. Again, if you're not guided, you can put in whatever you'd like for that top value. We know how to calculate the price. It's 10 cents a text message. So here, I would go ahead and get all of these values. 50 cents, 60 cents, 70 cents, or 80 cents. So the question is this a proportional relationship? Well, is 4 to 40 cents the same as 5 to 50 cents and 6 to 60 cents? That's what we need to figure out. So, are these equal? Again, lots of different ways to do it. Let's say we go ahead and multiply by 100. I'm just moving the decimal points over. I could even simplify now, or you can just divide out what is 400 divided by 40. You will get 10. 500 divided by 50, it's 10. And you will see that when you compare the other ratios, you'll get the same effect. 10 cents is what it costs per text message. So this is a proportional relationship, and we continue getting that constant ratio. So yes, this is a proportional relationship. Because we have a constant ratio. You know, basically it's 10 cents per text. Okay, now let's go ahead and talk about how we can develop an equation for proportional situations. The format of the equation we are going to use is this, y equals kx. This is referred to as direct variation, and we'll come back to this later on in the school year. K is a unit rate. It does have some fancy terms, I will let you know, so that when you read them in your book, you're not like, what is that? This is called a constant ratio. It is the constant of proportionality. So I'm not going to write that down because I don't want to confuse anyone, but it is referred to as the constant of proportionality. Let's see how we can use this in a given example. So what I'd like you to do is to take a look at your handout flip it to page 24. And let's take a look at babysitting, number 2. Because I'm sure this is a situation that you guys will find yourselves in at one point or another, if not already. Okay. And we would like to write an equation for the situation here. So Gloria earned $26 for babysitting 4 hours. There's a rate. Let's go ahead and write down the rate that we are given. $26 per 4 hours. Again, we're putting our money on top. Write and solve an equation, so we're told to do this, to determine how much Gloria would earn after babysitting 25 hours. Now, I will say there are many, many different ways to solve this, but what we are going to practice is writing an equation of the form y equals kx. So we've seen this type of problem before, and we used unit rates to solve it. We are again going to use a unit rate. We're just going to then take that unit rate and substitute it into this equation. The beauty of an equation is that we can be given any amount of hours that Gloria could babysit and calculate her earnings, as opposed to just figuring out, one answer to this one question. So let's see how to do this. First of all, I need to create a unit rate. So step 1, find the unit rate if you don't have one already. So instead of $26 for every 4 hours, let's go ahead and divide, and when we do that we find that she earns $6.50 per 1 hour. So calculate that unit rate. Step 2, I'm always going to use y and x. It doesn't matter though, you don't have to use those variables. It's just helpful because when you go to plot this on a graph, you're working with x and y's already. But if you wanted to use h for hours and c for cost, that would be fine as well. Let's define our x and y. We have 2 variables, we have 2 things that we're trying to figure out. But let's go back to the statement. It says write and solve an equation to determine how much Gloria would earn. Okay, so we're trying to figure out how much she's going to earn. That's what we're calculating, so that's going to represent y. Money earned. We always want to know what it is our variables represent, otherwise the problem won't make much sense. It says how much Gloria would earn after babysitting 25 hours. So we're talking about a number of hours. That is going to be x. I am not going to work with the number 25 yet. Okay, that comes after we have the equation. So step 2, define x and y. Okay, so I know y equals kx. K is determined by my unit rate. I'm just going to put 650 in here. I don't need to worry about units in the equation itself. I'm just going to call that step 3. Substitute the unit rate in for K. Okay, now that we have our equation, we can figure out what Gloria will earn after any number of hours given. What were we given? 25 hours. So she's probably been babysitting for the same family a little bit every day after school. So we know we are given 25 hours. We want to substitute and solve for y. So again, here's my equation, 25 hours, and it makes sense to substitute it in for x because x is the number of hours, and ultimately if I take 650 an hour and multiply it by 25, I should figure out the total money she earns. And when we do that, we get y equals $162.50. So 2 parts. Part 1, we got the equation. Part 2, we solved for a specific. How much will she earn after 25 hours? But like I said, what's really great about this equation is that we can use it to find other values. We will practice this a lot more tomorrow. I'll see you then.